In this video, we're going to find a polynomial function with a given real zeros whose graph contains a given point. So by definition, and this is something that you always have to remember whenever you're finding a polynomial function with a given real zeros given a point. So if r is a real zero of a polynomial function f, then x minus r is a factor of f. All right, and as a consequence of this definition, r is an intercept of the graph of f. So r is a real solution to the equation f of x equal to 0. So on this question, the factor of f, which corresponds to the 0, -3, is equal to x minus -3, and that gives you x plus 3. So we are looking at the first 0 here, which is -3. And the next one, okay, which is 0. The factor of f, which corresponds to the 0, is x minus 0, or you can also call it a s. Then for 2, the factor of f, which corresponds to the 0 of 2, is equal to x minus 2. Then for the last 0, which is 3, so the factor of f, which corresponds to the 0 of 3, is equal to x minus 3. So these are the factors that we have. We have x plus 3, we have x minus 2, and we have x minus 3. So as a result, any polynomial function of the form fx equal to ax, so I'm going to multiply, we're going to multiply the a by the factors that we found using the zeros given on the question. So a times x, which is this x, then we have x plus 3, we have x minus 2, and we have x minus 3. Okay, so any polynomial function of this form where a is a non-zero real number qualifies. Okay, and the value of a causes a stretch, compression, or reflection, but it does not affect the x-intercept of the graph. Now we're going to solve for a. So in solving for a, we're going to substitute the values x and fx for the point. So the point given on the question is -1/2 and -350, where -1/2 is your x value. Okay, so wherever you see x in this fx equation, you plug in -1/2. And the -350 here is your f of x. Okay, so it's just like having x and y point, or x and y coordinate. Your f of x is your y coordinate, which is -350. Your x coordinate is -1/2. So we're going to substitute these values into this equation and solve for a. So we have -350 equals -1/2 times x times a, sorry. Okay, x is -1/2, and we have -1/2 plus 3, -1/2 minus 2, -1/2 minus 3. Now we're going to simplify. So -350 equals negative. So a times, I'm just going to switch it around. Okay, multiplication is commutative, so I can still write this as a times -1/2. Then I'm going to simplify -1/2 plus 3. So if you type this into your calculator, this will give you 5/2. And -1/2 minus 2 is negative 5 over 2. And the last one, which is negative 1/2 minus 3, is negative 7 over 2. All right. Now we come down. We have negative 350. We're going to simplify it further. And we're going to have our a outside. And we're going to multiply all these numbers, all these fractions together. So we're going to multiply the numerator values. So negative 1 times 5 times negative 5 times negative 7 gives you negative 175. And if you multiply 2 by itself 4 times, that gives you 16. So we have, I'm going to bring this to the side. So negative 350 equals negative 175a. So this can be written as negative 175a over 16. At this point, to solve for a, we're going to apply cross product. So we're going to multiply negative 350 by 16 and equal that to negative 175a. And negative 350 times 16 gives you negative 600. Sorry, negative 600. Sorry. And this gives you negative 175a. And to isolate a, we're going to divide both sides of the equation by negative 175. So your a, okay, I'm going to bring this one here. I'm running out of space. So your a is equal to 600. Okay, so negative will cancel out. So we're going to have a positive value in the end. So 600 divided by 175 gives you 32. So your a here is 32. And now we're going to plug this back into the original equation. We're going to plug a into this original equation. So our equation now is f of x equals 32 times x minus x plus 3, x minus 2, and x minus 3. Right? So this is how you write or find a polynomial function with the given row zeros whose graph contains the given point. All right? I hope this helps. Thanks.